Okay, trig identities. I'm going to prove all of these for you. I'll prove this one and I'll show you how these two guys come from that guy. But you really I guess what it'll boil down to is you need to memorize them. But because you need them at your fingertips. However, I will show you how they're derived, okay? A trig identity is an equation that is true for all values of the variable for which the expressions of both sides of the equation are defined. So this is always true, but when cos x equals 0, it kind of falls apart, but we don't worry about that. For trig identity purposes, we just hold they're true, even though, sometimes if cos x is 0, you can't divide with 0. We don't worry about that in this situation at all. Okay? I just want to correct this before. Okay, so I want to prove these. I want to show you where these come from. Do you recall that if you have a terminal arm in any angle in standard position, and if there's a point xy on the terminal arm, that this is equal to x, and that distance is equal to y, and that hypotenuse we call r. Do you remember when we took that? Okay, so just recall that in the previous unit we defined cos theta as x over r, sine theta, right? It's just opposite over hypotenuse, is y over r, and tan theta equals y over x. So far, so good? I'm going to be using these ratios to prove these original trig identities. But once I do this, you will never use this method on your test again. You will not use this method on your test, okay? The idea of the test is to see if you can manipulate with these trig identities, not x over r. So on the test, do not use this method. All right, so the first one is tan x equals sine x over cos x. So what we do, whenever you do a proof, you always separate the left side from the right side. So left side equals tan x, right? The left side, and tan x equals sine x over cos x. Agreed? No, for heaven's sakes. I'm trying to prove that. I can't just state it. Tan x equals y over x. So far, so good? Opposite over adjacent. We're good with that? Yes.
So is that angle S?
Left side.
Oh, left side.
Left side, yeah. Oh, okay. That's a LS. Yeah, that's funny, actually. Okay, right side equals sine x over cos x. Now, you know that the right sine x is equal to y over r all over cos x, which is x over r. So far, so good? Right? I'm just using this. Now, when I divide by a fraction, I multiply by the reciprocal, y over r times r over x, and that reduces to y over x. Normally, we only write one equation per one equal sign per line, but because of space, I'm kind of cheating a little bit. Do you agree that the left side equals right side? Okay, so therefore this trig identity is true. We've proven it, right? Tan x equals sine x over cos x. Got it. All right, fine. Let's prove cotan x. So let's do cotan x equals cos x over sine x. So again, whenever you're proving, does anyone still need this bit? Did everybody get that? Okay. Left side equals cotan x, and that equals what? Well, if tan theta equals y over x, then cotan of an angle is equal to, huh?
X over Y.
Okay, good. All right, right side equals cos x over sine x, and cos x is x over r. Sine x is y over r. When you divide, you multiply by the reciprocal. That equals x over y. See, so you see left side equals right side. That means we did it. Check, check, check. Right? I'm just checking off what we've proven. Okay. Let's do the Pythagorean identities. Sine squared x plus cos squared x equals 1. Do you agree that left side equals sine squared x plus cos squared x? Right? So if sine of an angle equals y over r, then sine squared of an angle just is equal to y squared over r squared. If cosec theta of an angle is x over r, then cos squared of an angle is x squared over r squared. So that is equal to y squared plus x squared over r squared. Now using the Pythagorean theorem, can anyone tell me what x squared plus y squared equals?
R squared.
Yeah, x squared plus y squared equals r squared. So that r squared over r squared, and that equals 1. Right side equals 1, right? Right side equals 1. Left side equals right side. We know that this is true, so check. Now, I'm not going to prove these two guys. I'm going to show you where they come from. These two guys come from this top Pythagorean identity. So I can use this to derive this. I can use this to derive this. So watch. Sine squared x plus cos, cos squared x equals 1. Now, what would happen if I divided everything by cos squared x?
It would be sine squared x equals to. Oh no.
We divide everything by cos squared x. So notice what I do to the left side, I do to the right side. I'm not changing the equation. I'm changing the appearance of the equation or the form of the equation, but I'm not changing anything in the relationship. What does sine squared x over cos squared x equal?
It's sine squared over cos squared. It's sine y squared over x.
Huh?
Y squared over x.
No, what we wanted, tan squared x. Yes. Does everybody see that? Because tan x is sine x over cos x, so tan squared x is sine squared x over cos squared x. Plus 1 is equal to, what's 1 over cos squared x? Yeah. Oh, so do you see how we got that? I didn't prove it, I just derived it, okay? Now we could do the same thing, but instead divide by sine squared x. So I'm deriving. I'm not really proving, I'm deriving. See, when I'm deriving, I'm not separating the left side from the right side. See, I'm going to derive the other one. It's not really a proof, but it's good enough for us. So sine squared x plus cos squared x equals 1. Now instead of dividing by cos squared x, I'm going to divide by sine squared x. Oh, sorry. So can you see that sine squared x divided by sine squared x is 1? cos squared x over sine squared x is cotan squared x, and that equals cosecant squared x. So there, I got this, the third Pythagorean identity, right? And these guys, you know, cosecant is the reciprocal of sine, secant is the reciprocal of cos, cotan x is the reciprocal of tan, right? These guys are reciprocals of each other. Can I explain anything any better? That's a v there, we're just deriving. So let's actually do it. Let's do it. Here's some, always remember, work with the left side and right side separately. Exclamation mark, exclamation mark, exclamation mark. Right? That's how important it is. Yeah. 1, 2, 3. That's a good one. You cannot assume the equation is true. You have to separate them. Work from the complex to the simple. So we're going to, like in this example, can you see the left-hand side is more complicated than the right-hand side? So we'll start with that side first. In many cases, it helps to convert everything to sine x and cos x. Okay. Work with, sometimes you have to work on the left side and the right side. You do what you have to do to make them equal. And we use algebraic manipulation along with basic identities to prove the formulas. So let's start with this guy. Prove the following identities. Left side, so I'm going to remind you, never use X, Y, R. I'm referring to the test. Use the trig identities. That's what I'm looking for. Okay? Use the trig identities. Okay. Left side is 1 minus cos squared x over sine x. Okay, what identity would you go to kind of maybe simplify this expression, right?
Sine squared x.
Huh?
Sine squared x. Like you sine 1 minus cos squared x equals sine.
Okay, so out of the Pythagorean identity, absolutely equals 1. So sine squared x equals 1 minus cos squared x. So could you see how I can put a sine squared x there? Do not skip steps. And sine squared x divided by sine x is sine x, right? Ooh, right side equals sine x, left side equals right side, therefore it's true. Huh? Not too bad, right?
The right side you're missing an X.
Sorry?
On the right side you're missing an X.
Oh, my bad. Thank you. Got to get everything, you know, otherwise it's a communication issue. Okay, let's try number 1b. Left side equals 1 minus cos squared x times 1 plus cotan squared x. Well, what is 1 minus cos squared x equal? Yeah, that's from the last one, right? Do we have anything that converts 1 plus cotan squared x?
Yes, cosecant squared x.
Perfect. So that equals sine squared x times 1 over sine squared x. What does that equal? 1. Right side equals 1. Left side equals right side. We've done the job. We did it, yes.
So are we allowed to like move things over the equal sign?
No, you have to separate. You can't assume it's true.
Uh,
Separate left side from right side. Yes?
Every time we're just trying to make sure that left side equals right side.
Yeah, that's what proving means. We make sure the left side equals the right side.
So like
And proving is all we're doing for identities.
Sorry?
We're just proving when it comes to identities.
Yes.
And is there any case that, like, on a test we get a question where it's actually not true? Like,
No, we wouldn't do that to you. Because, you don't know.
So if you just say left side equals right side, then you get the point.
If what?
If you just
But it's, yeah, we know it's going to be true.
yeah, so you say
Oh, you wouldn't get a mark.
I mean, it's just like
You have to prove it. Okay, there's a little trick you can do. Do you remember what a conjugate is? Right? They're identical, but the signs are different, conjugates. So we're going to multiply this by the conjugate of 1 plus cos theta, because if we multiply by 1 minus cos theta, you'll see what we get, and we eventually get sine squared theta, because sine theta is on the bottom. Huh? It had to do with solutions to quadratic equations. Do you remember when you're rationalizing the denominator,
yeah.
we multiplied by the conjugate? Yeah. Okay, left side equals sine theta, 1 plus cos theta. So we're gonna multiply by the conjugate times 1 minus cos theta over 1 minus cos theta. Good? Okay, so we have, huh? Yeah, we're multiplying by 1. So that's why you multiply anything by 1, you're not changing anything. We're just changing the form, but the equality will still hold, assuming it's true, right? Sine theta times 1 minus cos theta all over, we have the FOIL, right? 1 times 1 is 1. 1 times minus cos theta is minus cos theta. Cos theta times 1 is plus cos theta. Positive times the negative is minus cos squared theta. That must have been the cutest little sneeze I've ever heard. So that is sine theta times 1 minus cos theta is 1 minus cos squared theta. So far, so good? Because minus plus, that's just 0. Okay. Now, what does 1 minus cos squared theta equal? Yeah. So that divides out and you're left with, right, that divides out. So we're left with 1 minus cos theta all over sine theta. Can I explain anything better? Yes.
Wait, how is it that sine theta over sine squared theta cancels out?
Do you agree that
No, it doesn't cancel out. There's still sine theta.
just the square, the exponent? Yeah.
Why don't we try the numerator to sine theta? The 1 minus cos theta.
Oh, it has to be 1 minus cos squared theta. Right? Good, are we good here?
Just 1 second.
Okay. With practice, it just happens. The things you have to memorize are these. All 8 of them.
Will we get the gist?
Brian, next year you'll have like 20 of them
Really? Yay.
in advanced functions. Because
Is every
Wait,
unit in grade
can I
12
just see
hard?
it for like 5 more
I
seconds?
don't think so. Yeah, sure. Is every unit next year hard? I don't think so.
My brother like failed math.
Huh?
My brother did really bad in grade 12 math. So I'm expecting to do really bad as well.
Excuse me, so isn't 1 minus cos theta sin theta? Or am I off?
No, it's as we cos squared theta.
Oh,
That's what I asked.
Okay, let's look at this guy. Oh my. Here, let's use the trick. Convert everything to to sine x and cos x, right? So you can express tan x as sine x over cos x. Let's do that, okay? That's that trick where it said, do you remember it said, in many cases it helps to convert everything to sine x and cos x. So that's what we're going to do, okay? So which side would you think would be most complicated?
right side.
Yeah, because it's not in terms of sine x and cos x. So right side equals tan x over 1 plus tan x. So tan x is equal to,
Sin over cos x.
ooh, I'm impressed, sine x over cos x. I'm going to change that tan x to sine x over cos x. Now, if I want a common denominator so I can add them to, what should I change 1 to?
Cos x over cos x.
Cos x over cos x. Because you know anything divided by itself equals 1, right? So we have an equivalent expression here. That's no problem. So now we have sine x over cos x, right? That's your numerator. And then this is going to, we'll bring them together. Cos x plus sine x over cos x. That's all together. We'll bring that over here. So when you divide by a rational expression or a fraction, you multiply by the reciprocal. So you have sine x over cos x times cos x over sine x plus cos x. These guys divide out, and that is equal to sine x over sine x plus cos x. So left side equals right side. We've done our job. See, here we started with the right-hand side and moved and converted it to the left-hand side.
So are we supposed to just pick whichever one's more difficult?
Usually work with the more complicated because that's pretty simplified, right? So
Solve it with the left side?
at this point in time, I don't know how you would. Yes,
We always want to tackle the thing that, the side that doesn't have cos or sine.
usually, yeah. Yeah, usually. Most of the cases, I can't say in the 100% of the cases, but it's a pretty good strategy. A lot of times you're playing with it and then you realize, oh, that didn't work, let me try something else. Okay. Ooh, what do you think we should do here?
Should change up the left side.
Change. Well, no, we're doing the right.
Should we work with the left side or the right?
Should you know what, change a tan to like cos or sine?
This one's a little different because what does 1 over tan squared x equal?
To cotan.
Squared.
So left side equals 1 plus 1 over tan squared x. Doesn't that equal 1 plus co-tan squared x? And what does 1 plus... Oh, I'm sorry. What does 1 plus co-tan squared x equal?
Cosecant.
Yeah, it's your Pythagorean identity, yeah. Of course that's it. It's very good. Cosecant squared x.
Could that be the question on the test?
Oh, wouldn't that be lovely? You see, so sometimes, sometimes we could have converted everything to sine and cos. Vala, we could have done that.
Yeah.
However, this was easier.
Yeah, sure.
You know. Okay, ready? What side do you want to work with?
Left side.
So this, we could convert everything to sine and cos, but I'm wondering what does 1 plus tan squared x equal?
Cosecant squared x.
Wait, isn't
It equals
Secant squared x.
1 plus tan squared x
it's cosecant?
no, just secant squared x.
Isn't it 1 plus?
No.
Oh, it's right here. What's 1 plus tan? I'm sorry. What's up?
Are we good with that? That's from one of the Pythagorean identities. Now, the other class had trouble seeing this, and so I'm going to do it like this. Do you agree that this is the same as secant squared x times 1 over 1 minus tan squared x? Do you agree that that's the same thing? Well, except I misspelled secant. That's no good. Are you guys okay with that? What does secant squared x equal?
1 over cos squared x.
Yes, perfect. So far, so good? So this is 1 over cos squared x times 1 minus tan squared x. So far, so good? Okay. All right. So I'm going to convert this to sine squared x over cos squared x. 1 over cos squared x times 1 minus sine squared x over cos squared x. There. Now I'm going to multiply. I'm going to distribute, right? Cos squared x times 1 is cos squared x. Cos squared x times sine squared over cos squared x. The cos squared x will divide out. So this is going to be 1, right? Cos squared x times 1 is cos squared x. And then this times this is,
Negative sine x.
yeah. So left side equals right side. We did it. We proved it.
It seems so easy when you do it.
Yeah, you know what? Watching me, this is not a spectator sport. You need to do it. You need to practice and learn how to manipulate the equations and get comfortable. Are we good with that?